Okay, we are doing section 7.5, which is special types of linear systems. Now, we talked about in section 7.1 when we had the intersection of the two graphs, that was called a consistent independent system, and that was when we had one solution. If we have an inconsistent system, that is a linear system with no solution. Or a consistent dependent system is a linear system with infinitely many solutions. Show that the linear system has no solutions. What we're going to do is graph both of them. This one we'll do in blue. We want to get them in slope-intercept form, so I'm going to subtract 3x from both sides, and then divide by 2. Okay, so I start at 5, and I go down 3 over 2. Okay, I'm going to graph the bottom one in, green I want to do. So same thing, I'm going to subtract 3x, divide by 2. I start at 1, and I go down 3 over 2. So no solution. It looks like when we have no solution when we graph two lines that they are parallel because parallel lines don't intersect. Therefore, they don't have any solution. So what does infinitely many solutions look like? Well, the same thing. We want to go ahead and get them both into slope-intercept form. The bottom one is done, but the top one we need to rearrange by subtracting the x first, then divide by -2. So it'll be positive 1/2 x plus 2. I'm going to start at the 2, up 1 over 2. Okay, and our other equation, the second one, is actually the exact same equation. So I start at 2, go up 1 over 2. And when you have a straight edge, which I do not, they would be the exact same lines. So when the equations represent the same line, it's infinitely many solutions. Instead of writing infinitely every time, you can just do the infinity symbol. And I will get what you mean. It's much quicker than writing infinitely many times. Okay, so down here we are going to solve the equations using substitution or elimination, which we know how to do, to figure out whether the system has no or infinitely many solutions. So this one is already set up, number 1 is already set up for us to do elimination because all the variables are lined up. If we add, the whole left side goes away, negative 5x and 5x cancel, 3y and negative 3y cancel, so we get 0 equals 9, which tells me right there that's no solution. And then number 2, we're going to do substitution with this y. Put that in right here. Negative 6x plus 3 times 2x minus 4 equals negative 12. Distribute. The x's cancel. We get negative 12 equals negative 12, which is true, so it's infinitely many solutions. If you use substitution or elimination to solve what your homework will ask you to do, and you just get an answer like x equals 4, then we know that it's just one solution and you can continue on like we would have in the previous sections. Okay, there's also another way to figure out how many solutions we have. If we have one solution and we are in slope-intercept form, our equations will have different slopes. We will know right away that it's going to be one solution. For a no solution situation, you're going to have the same slopes, but you're going to have different y-intercepts. So your b's will be different. And then lastly, our infinitely many solutions situation. You're going to have the same slopes and the same y-intercepts. It's going to be the same line. Okay, so this is in slope-intercept form. Okay, so it says without solving. So on the previous page we solved using elimination or substitution. This says without solving, tell whether the linear system has one, no, or infinitely many solutions. So what we're going to do is get them both into slope-intercept form and compare their slopes and y-intercepts. So the top one, I'm just going to subtract that 5x and it's going to be done. The bottom one, I'm going to add the 10x, divide by -2. So we have the exact same equation. The red and the black are the exact same, so this is infinitely many solutions. And on B, if I solve the top one, and then I solve the bottom one. Oops. I want to do that in blue so we could tell the difference. Here we go. We have the same slopes but different y-intercepts. So these are going to be parallel lines, so this is no solution because they would never intersect. Okay, last problem. We have an artist who wants to sell prints of her paintings. She orders a set of prints for each of her 2 paintings. Each set contains regular and glossy prints. Find the cost of one glossy print. So we have one of our equations is 45x plus 30y equals 465, and the other is 15x plus 10y equals 155, and we want to use substitution or elimination to solve this. If I multiply the bottom by -3, I can see that our y's will cancel. So the top stays the same. And the bottom turns into -45x minus 30y equals -465. And I add everything down, I get 0 equals 0. Which is true, but that doesn't help us solve for the cost of a glossy print. So once we get down on a word problem to 0 equals 0, we say, we don't know, we need more information. They didn't give us enough information. Okay, and those were the special types of linear systems in section 5.